blizzard warnings, snow squall warnings, extreme cold warnings. We've got a multitude of alerts, watches, and warnings all across the United States. Plus, record-breaking cold air is set to plunge into the lower 48. I'll have all the details and a look at our major upcoming winter storm as a new episode of Cold Rain's Weather World starts right now. Hi folks, and welcome to the channel. My name is Jason Pritchard. I'm your host of Cold Rain's Weather World. I'm so glad that you're here today. I hope your Monday is going well. I woke up this morning with a little bit of a foggy head, and so hopefully this will not affect us too badly as we go along through the course of this video. Our trivia question of the day has to do with fog, so we're going to get into that here in a moment. Before we do though, if this is your first time here, welcome to the show. We cover most of what we cover on the show is related to weather, upcoming weather, current weather, long-range weather outlooks when appropriate, and all of that good stuff. But we'll talk about other things occasionally as well. And so today we've got on the docket cold air plunging into the northern part of the country. We've got record-breaking cold that's going to unfold across the central part of the country, and then we've got a winter storm that's going to take shape and affect the lower plains into the south and southeast. And so we're going to cover all of those things. Before we do that, though, I want to ask you to subscribe to the channel. If you like what you see, drop a like in the like button. That all helps us out. It helps us grow. YouTube will push this out to more people, the more interaction that happens with a particular video. You can turn on the bell notifications if you want to be notified when new videos drop. We drop these about once every day or two, just depending on what's going on with the weather. We've had a lot going on, so we've been doing daily videos. The other thing is, if you want to leave a comment in the comment section, I would really welcome those comments about the show, suggestions for the show, and any other questions that you might have, and certainly prayer requests. I want to pray for you if there's something going on in your life that's very difficult. I want you to, list that in the prayer, list it as a prayer request in the comment section, and myself, other folks can pray as they see the need to do so, and we certainly want to lift you up and encourage you. I was reading in Romans this morning, actually, that suffering leads to character, and character leads to hope, and Paul was saying that we should rejoice in our suffering. That's really, really hard to do, but we can take courage that other people are praying for us, and take heart that we're not alone in the things that we're going through. And so I want to be there for you if there's a difficult issue in your life. Certainly want to pray for you. So that is all that said. As I said, we've got a lot of stuff on the docket today. We're going to start here with our trivia question. And today's question, as I said earlier, is about fog. And so the question is, what type of fog forms when warm, moist air moves over a cold surface? Is it A, radiation fog, B, advection fog, C, evapotranspiration fog, or D, freezing fog? Okay. So if you know the answer, don't shout it out. We don't want everybody else to hear it. Just put it in the comments section or hold it in your mind, and we'll talk about it at the end of the show. I'll give you the answer as we get to the end of today's video. So today's weather roundup is going to start us off with the satellite imagery, and we'll put the satellite into motion. And you can see as a nice contrast to the last couple of days, there's just not a lot going on. The storm system that's affected the East Coast is well off shore. A remnant portion of that's up here across northern Maine, where they're seeing a little bit more snow that's yet to fall, and winter storm warnings are up for that. Lake effect snow is taking shape over off of Erie and Ontario. And then we've got some high clouds and some light snow falling here in Kansas and to Iowa, but nothing too major. We've got some snow falling in the northern mountains, Rocky Mountains up here. And the energy that's going to come together to make our winter storm, part of it is coming onshore here. Another piece of it is up here in Canada that's going to be dropping down. Can't really see that well on this image, but trust me, it's there. So this is just now coming onshore, and you can see these clouds associated with that. Now, if we take a look at the radar image, snow falling up here in Montana, light snow over into Nebraska, Kansas, Iowa, Missouri, and then those lake effect snow bands that I showed you, and then the snow up here in the Northeast is all pulling out. You can put this on into motion really and see that, but it's just, not a lot of organized activity going on. But that's about to change in a big way. As I said, a winter storm is going to take shape here. Before we get there, though, cold weather is going to be dominating the central portion of the country. That's going to slide to the east and lay the foundation in the east for a little bit of cold air damming and winter weather over in the east. And we're going to take a look at all of that. Now, here's our national hazards map, and as you can see, all of those extreme cold warnings here. And take a look at this. So a lot of these extreme cold warnings are going to be in effect for multiple days, up to Wednesday to Thursday in some spots. We've got extreme cold watches as far as southern Texas almost, so down into Austin over to Dallas. Looking very cold down there. Now, it's not going to be as cold here as it is up here in the northern plains. And then we've got winter storm warnings in effect already for the storm system that's going to take shape over the next couple of days. Flood warnings still in effect for Kentucky, where we've got river flood and stream flooding going on from all the rain that we saw. Winter weather advisories in West Virginia. Blizzard warning here in southwestern Pennsylvania and northeastern West Virginia up in the high peaks. It's very windy. As you can see, all of these warnings up here, these kind of gold warnings are high wind warnings. This brown are wind advisories. So lots of winds still blowing here. Not a lot of snow is going to fall with this blizzard warning, but winds are going to gust to 60. Blowing snow is going to take place. It's already snowed. So it's going to blow all around. And we even got a little snow squall warning here up in New York State with lake effect snow band warnings up here in north central New York. So you see all of our warnings and watches that are in effect. If we look at our temperatures, let's go to our temperature map here, and we can see this cold air up in Canada. This is set to plunge south. It's already doing so. As a matter of fact, if we drill in here on the temperature map a little bit, we can see this. I can pull this around. These are, let's go back to actual temperatures. So minus 26 Minot, minus 22 Bismarck, minus 15 in Grand Forks, minus 6 in Duluth, Sioux City, minus 1, minus 5 in Rapid City. So you can see where the purple and blue meet. This is where the 0 Fahrenheit line is. And so anything north of that's below 0, anything south of it's above 0. So you can see a wide area of very, very cold temperatures. This is going to plunge into the central part of the country here and then spill east and set the stage for our storm next week. Now, if we go back to our hazards map, oh, actually, let's do one more thing quickly. Let's just look at the wind chill. So you can see, look, minus 43 in Williston, minus 44 in Minot. So these wind chills are very cold, minus 50, 51 just over the border. Some of these places are going to experience multiple days of well below 0 with wind chills toward minus 60. I mean, that's just brutally cold. You got to stay inside up there. So back to our hazards map, we can see all of these hazards again. I'm going to click here and we'll take a look at this snow squall warning. That's kind of neat. You can see it here on the map. High wind warnings everywhere, lake effect snow warnings coming off of Ontario. And if we go to our radar, we can see those bands. And I think that's that band is kind of shrinking here, so that snow squall warning's just been discontinued. But you can see rates probably 1 to 2 inches per hour here. Very intense. Driving through this, you probably get through it in 5 minutes. Probably take you longer than that, of course, with having to drive slow. But it's very, very narrow, as you can see, and then other bands are coming off. So snow's going to fall in here. It's going to pile up a little bit. Not the worst lake effect snow machine we've ever seen crank up, but certainly it is coming down. Now, our temperature map, and I'm going to drop over here to a different display. We can see this a little bit better. So let's go here. I clicked on a sounding. We're not going to do soundings today, folks. We're going to do something else instead. So we're going to come up here and look at our temperature. So this is 850 millibar height anomalies. So what the temperature looks like about 5,000 feet off the ground. And this is just brutally cold. You know, we've seen this for days setting up. And so putting this into motion over time over the next 12 to 24 hours, we're looking at it just plunge right in through the Dakotas into the center part of the country. And all of this is going to continue to sink south. The core of it's going to be over here just east of the Front Range of the Rockies, out into the plains. But you can see it nosing on into the east. Now, this is important because this is going to filter down the east side of the Alps and set the stage for a winter storm in the Carolinas and up into Virginia. A couple of days ago, it looked like this was going to be a major storm that affected much of the East Coast, but as it's trended weaker over the last 2 days, we're in a spot now where it looks like Mainly the effects are going to be felt from Kansas, Oklahoma, Missouri on east into Tennessee and Kentucky, maybe the upper portions of the South through these states, and then into upstate South Carolina and North Carolina and Virginia. So um, a fairly narrow corridor of snow, whereas the other day it looked like we're going to have a big East Coast winter storm. Some of that could still change, so there's time, but that's what's happening here with this cold air. We'll put this back into motion, and you can see as we get on into um, uh, you know, later on into the week here, Friday, Saturday, it swings on in. This is the European model, by the way. So cold temperatures here for at least a week, and then we start to see some moderation take place. And also, if you look at the actual air temperatures, you can see those are the anomalies. These are actual temperatures at the surface. So minus 20s, minus 30s coming in. You can see that brutally cold air. It continues to plunge south, minus zeros, minus single digits down here into Kansas, into even maybe northern Texas. We get to zero, and all of this pushes off. This is going to be record-breaking cold. So it's just very, very cold, and that still hangs on. You see, that's we're into Thursday now, and that air is still extremely cold, and that bleeds east, and of course it's going to set the stage for that winter storm. And it's still, we're looking at 30s and 40s for highs, even as far out as Sunday. So winter is hanging on, folks. It's got its icy grip on the United States, and it's not letting go anytime soon. So back to our other display. Now so we're going to dive in now and take a look at what's coming up with this winter storm. Okay, so I'm going to roll this back just a little bit, and you can start to see this come together. This is the European model. Other models show very similar outcomes, so we're not going to jump through every single model today. But the Euro is a good model. We're going to roll it back a little bit, and so late Monday night into early Tuesday morning, we start to see snow breaking out over Nebraska into Kansas, northern Missouri, and we put this in motion here, and you can see it really start to take shape over Texas, Oklahoma. We've got rain down here and some ice in between, and then these dark blues are heavier snow bands. So we're going to see those break out and move on to the east over time. Big high pressure, 1052. I talk about this sometimes, and you probably don't have a lot of context for it, but usually you see these big Arctic highs come in. They're like 1040, 1045. We've got an extension of that down here in Nebraska. But this 1050, when you start to get into the 1050s and upward from there, that's pretty massive. And the reflection of that at the surface is cold, cold, cold. And you've seen that on the temperature maps that I just showed you. So big high pressure. When you see these big high pressures come in, if you've got any sort of storm activity, you're going to get a winter storm somewhere. And so we're going to roll this forward, and you can see the precipitation move off into Tennessee and Kentucky, rain across the deep south, and rolling that on forward here. Let's go back one slide. It went too far on me. So snow breaking out in North Carolina. This is Wednesday in the morning. This is going to take shape. The snow is going to move in Wednesday in the morning. It's going to snow through the afternoon in some of these spots here. And just clicking this forward, you see these dark blue snow bands. So the European thinks that northeastern North Carolina and southeastern Virginia is the place to be to pick up the most snow. Other models tend to have this maybe up into Virginia a little bit more. The National Weather Service thinks that's probably going to be the case. But we'll have to see how it all plays out. There's definitely going to be track shifts and strength of the storm shifts and all of that kind of stuff as we go through the next couple of days. And we start to see some of the high resolution models get into a good range where they can identify cooling, warming in the mid layers, low layers, and start to flesh out where the precipitation types develop. But that low takes place, kind of moves across, it reforms off the coast, snowing still as we get into early Thursday morning into the overnight hours, Wednesday night into Thursday, and it pulls on off. And another that upper level system that we coming out of Canada, it kind of comes in on the Euro shows this now. So other models don't show this, but it comes in on the backside. It doesn't quite link up with the system like we were thinking it would earlier. Instead, it remains a little bit separate. It produces its own lift, and you got another little area of light snow coming through. So how these two pieces of energy, and we've been talking about this, how they interact will matter a great deal in terms of how this storm evolves. So cold, high pressure plunging in after the storm is just cold, cold, cold. And if we get snow on the ground, we could be talking about single digits for lows. So here are your temperatures these are at 925 millibars. So, 1,000, 2,000 feet off the ground, you're looking at 925 millibars. And the reason we're looking at this is because yesterday we looked at soundings to see if there were warm layers. Not going to go through that today, but this temperature shows us the actual 925 millibar layer. And what we're going to look for is to see, as the storm sort of moves through, where these, where the freezing line is. This line here, maybe I'll draw it on here and it'll help us out a little bit. But this is our freezing line right here. So just keep that in your mind. I'm going to remove this here in a second, but this is where our freezing line is. Now watch how this shakes out as we go over time here at 925 millibars. We're looking for warming to see if we're going to have snow or ice or something else. So we advance it along. The storm's unfolding here early Wednesday morning. It should be snowing. According to this, there's no big warm layer until you get down in here into southeastern North Carolina. So if there's precipitation falling down here, this is either rain or freezing rain, depending on the temperature at the surface. So going on through here, we see a little jump. So did you see that? This little jump up here, but then we push this on forward, and then we can see that 925 millibar kind of jump in here through the course of Thursday morning. So maybe some more icing in there, but then it retreats as the storm pulls away. All right. So we're looking at those little layers. We see the same thing here at 850 millibars. So those are the kind of layers we look at to see if there's any warming. So snow's getting ready to start unfolding across North Carolina, maybe upstate South Carolina. So we're good at 850 until we get down here toward Fayetteville and Jacksonville and on toward Wilmington. And then this moves on, and as we advance it, that line's, the freezing line's kind of creeping in, so we're starting to see a little bit of a warm nose potentially develop. The European doesn't really bring it all that far north and keeps the bulk of the precipitation snow. See, it kind of jumps up a little bit there, but then sort of stays in the same spot, retreats back over time. So what's happening, and you're not seeing this reflected, but we saw it on the map previously, there's the snow and the precipitation is breaking out during the time that I just showed you this. So we should see, according to the European, now anywhere from here, let's get the pin back on here, anywhere from here, really here to across here in this area, south of that should be where you would see mixing, north of this where you would see mostly snow. But this is just the Europeans' take on it. We'll need to really hone this in as we get into the event, but just know that that's what we're watching. As far as the snow totals go, you can see the Europeans got the kind of the snow footprint back out here into southern Missouri. Really picks up the lion's share of the snow, 6 inches to as much as maybe 10 to 12 inches. And some of the winter storm warnings that are in effect reflect that. So you could see a nice little footprint of snow here. And then over here, the European says, hey, northeast North Carolina, big winter up toward Norfolk. And everybody else gets a little bit of light snow. So the other day, it looked like a bigger area of snow, but today it's trended a little weaker. So we're not seeing a lot reflected there. Now, let's go back here and take a look at what the GFS is showing. So the GFS, what is it showing? It's a little bit bigger in terms of its footprint out here in the center part of the country. It extends this all the way back into Kansas, and you really get it into maybe 16, 18 inches of snow in spots here. But this is where we're kind of zoning in on the highest snow totals. And then the GFS is pretty similar here, but it's got most of the snow that the heavier snow that falls off the coast or into southeastern Virginia. It's not quite as robust on the precipitation, and therefore the layers don't cool quite as well. And so in North Carolina, you're missing out a little bit. There's just less precipitation. The GFS has the axis of heavier precipitation up in Virginia. So you can see some subtle differences between the model. That's not a big difference, in the grand scheme of things. But, if you live in Moorhead, or DC, you're right on the fringes of this stuff. And so a little shift one way or another could put you in the big snow or, keep you out of it altogether. So we're going to have to pay attention to that, see how it comes out. The European sleet forecast. So we saw the 850 kind of line creeping up here. So it remains just south of Wake County. I used to live in southeast Wake County, and boy, oh boy, oh boy, did we ever have a gradient through the county. And so this is where I live right here. And we would have a gradient. So right around where I live and on up here, you get freezing rain down here where the sleet is, and then snow up here in this area, and it was just terrible. Now I moved out into the foothills where we're in a mountain lee shadow zone. So up in this area here, you get northwesterly winds coming across these mountains. It comes down the mountain, it dries out, and everybody else is getting snow, and I'm here getting clouds, and sunshine. And it's not really sunshine. I'm kidding. But that's how it works for old cold rain. Cold rain just can't move into the right spot. But I love the mountains. I love to drive around and see the mountains. It's so much fun. It's beautiful, and it makes up for the we call this the snow screw zone here in Wake County. But you folks in Cary, man, you always get it. My buddy that lives in Cary, my other buddy lives in North Raleigh. Got another buddy lives in Holly Springs, Apex. We got buddies all over the place over here, and they're always on the good side, and I was always on the bad side. So freezing rain. Let's take a look at that. Enough about me. Weather, back to the weather. Freezing rain down here in southeastern North Carolina, and some freezing rain over in Arkansas. So now let's head over to the National Weather Service page. This is coming out of from Wichita. Okay, so the National Weather Service is who I would kind of go with in terms of reliability. They're not always going to follow the models exactly. When we're in the social media world and we're talking about it on podcasts and we're posting about it on weather boards, we're watching the models come in. We're kind of hugging those models. Hey man, the NAM just came in, big uptick in precipitation, big snow. Why is the National Weather Service only predicting 4 inches? Well, because they're very smart. They have expertise and experience in forecasting, and so they're going to predict. They're going to make a forecast that's an official forecast. It's going to affect a lot of people, and people are paying attention to that. And so they're not going to just jump around. It's going to take trending and analysis and all of the above, understanding of the science to come up with this stuff. So when we look at this, they're putting out here percentage of 4 inches plus, and then over here, kind of on the high side, percentage of potentially 8 inches plus. This is out of Wichita. So Russell, Salina, Topeka, Hutchinson, we're all in the 80s here, a little bit less as you get down here and toward Pratt, Harper, Emporia, 91. So 90% chance of 4 inches or more of snow is pretty good. I'd take it. And then 80% chance or 50 to 60% chance of 8 inches or more. Now, again, these things can change, but this is a pretty good idea of where the heaviest snow could fall. If we go a little bit to the east there and we look into let's see, where are we at here? So Springfield, Missouri, that's where I'm at. And so Springfield's putting out a little bit of a different map, but they're showing you, forecasting where the heaviest snow axis is going to be. So this is through Missouri. You can see down here Joplin 8 to 11, up here near Pittsburgh 8 to 12, Springfield 8 to 11. So anywhere in this orange shading, you're game for 7, maybe 10, 12 inches of snow in here. So going to be a nice snow for you guys. You're dealing with the system before it has a chance to worry about phasing, and so the short wave is a little stronger. It's going to produce plenty of lift out here, and so you guys are a little bit more solid with the snow forecast than we are back east. Now let's pop over here to Tennessee. What is Tennessee saying? So they've got kind of a map. Looks fairly good here to me. Less amounts down here as we get into northern part of Tennessee up toward Nashville, Lafayette, Clarksville, 2 to 4 inches of snow up here. So shouldn't be a massive deal out in this part of Tennessee. It's just not a strong wound up system. And so just light snows, moderate snows, maybe as you get back up toward Kentucky, but should be a nice little event here. And then if we get on into Greenville, Spartanburg, so this covers my area here down into Morganton, and you can see Morganton here. So generally light amounts into South Carolina, into the mountains, back into the foothills up here. North Wilkesboro Mount area looks like a good place to be to pick up a couple of inches of snow. That's the expected snowfall. Low end amount if things just crater out and don't do anything at all. High and dry for cold rain. Hickory, Statesville, Asheville, not even looking at that all that good. 1 inch. I'm just going to delete that map. I don't like it. I like this one better. 3 inches up to 5 inches, maybe even a little bit more than that, 6-8 inches. If things come together exceedingly well and we start to trend toward more precipitation, we've kind of trended toward less precipitation, which is obviously would create less snow, right? So this is a better map. I like this one better. But again, this is only 10% chance here, according to the folks at GSP. So um, outlier on both ends. So this is the best map to use if you're going to be in the Greenville-Spartanburg area and you're looking at their coverage area. Go with this map for now. And then a couple more stops here. So looking over into, this is out of Raleigh. And so this is Raleigh's expected total. So southeast Wake County down here where I am. So they're looking at potentially an inch of snow here, less than an inch down here. Some of this is going to mix with ice, sleet, freezing rain, things like that. And then as you get on up here into the northern part of the county, we get more snow, of course, as always. And then up here toward Roxborough, Henderson. Roxborough is always the place to be. Roanoke Rapids, you could see 5, 6, 7 inches of snow. This is a better place to be as it looks today. And so high end, we'll show that too, just for fun. 10% chance of this occurring, but it could occur. It's 7, 8, 9, 10 inches up here. So last couple ones we'll look at here. The last one is out of Wakefield, Virginia. And so this is really where the bulk of the snow looks to fall. 5, 6 inches, maybe as much as 8 in spots. As we get into Norfolk, up into Cape Charles, and all of this area in blue looks to be about 4 inches of snow. This could kind of work back down toward northeastern North Carolina too, based on some of the data that I'm seeing. So we'll keep an eye on that. And then here's our fun map again, the 10% chance map. So maybe as much as a foot of snow in a large area. So this could play out. I mean, there's no reason that it can't. The trends have not been favorable for this, but we'll see. I mean, things living in this part of the world for 30 years, in terms of Raleigh, the Raleigh area, I've watched these snowstorms every single winter, these winter events, and there's always trending to the last minute. Sometimes it's favorable, sometimes it's not. So this is not set in stone. We could see this play out in a number of ways. So pay attention over the next couple of days. I want to show you the last thing I want to show you here is the NAM. The NAM has just come in. I'm doing this video between 10 and 11 a.m. On the 17th. And so the new NAM model just came in, and I'm showing you the precipitation or the radar composite, what the NAM thinks the radar is going to look like. This is the 3K version. There are two versions of the NAM, the 3K, which is high resolution, and the 12K, which is also high resolution, but of course less. And so I'm going to roll this out, and you can see the snow streaming in. You always get a little finger of snow here coming out ahead of these systems, and so that's coming into Tennessee. Some of that's, or Kentucky, is probably not reaching the ground, but you can see it taking shape over Missouri, Arkansas. So the NAM's got some good snow banding back here breaking out. You guys are going to be snowing to beat the band out there. That moves, rain down here with maybe some thunderstorms, and then you've got sleet and freezing rain. And so this is going to move on off to the east. And look how it kind of falls apart. You see it's kind of robust here. Well, that wave weakens. The short wave that's producing this in the upper atmosphere starts to weaken as it goes east, which is unfortunate. If it would just stay strong, we could really get a nice snow out of this thing, but it's looking like it's going to weaken a little bit. The northern stream's kind of pressing it, shearing it out. And this moves off to the east, and you see the precipitation kind of break apart. And then as it gets over toward the Atlantic, it starts to re-strengthen. You get an area of low pressure redeveloping here off the southeast coast, and you start to see precipitation spread into North Carolina and really redevelop here, icing down toward Fayetteville, over into eastern North Carolina. You get a little sleet there, and then the precipitation filling back in toward where I live. So maybe I'll get some snow out of this after all. And then we'll click this forward just a couple of clicks, and you can really see it start to fill in there. So good snow, snows up into Virginia, North Carolina. So the NAM, and then it really is this, as it feels this upper level support from the northern stream, it starts to redevelop precipitation back out to the west. Now this is the NAM at the end of its range, and this is a beautiful map for a winter storm, but using the NAM at 60 hours is often foolhardy, and I wouldn't necessarily recommend it. It works really well 12 to 24 to 36 hours. Beyond that, it gets a little sketchy. So a lot of other models have this much drier. And so we will see, but I like to at least acknowledge the possibility that there is potential for precipitation. Now, this is the 3K NAM total precipitation output. So we're seeing a ½ inch down here, and it's still precipitating at this time. So this is not done, but that's what it's showing, 0.2 2 to 0.3 across North Carolina. It's pretty good. This is the 80. Well, this is the 12K NAM. So I'm showing this one too at 78. This is, you know, the bulk of the precipitation has fallen here, and you can see this. Look at this blue line. So take a look at this. Okay, I'm going to show it with yellow. This is the half-inch line right here. Look, see this? Anything in the blue is half-inch or more. You start to get into the yellows, you get into an inch or more. And so back here, look where old cold rain sits. Bam, the 12K doesn't like it at all. It'll just barely nothing there. All right, so I'm going to go to the next one. Now let's take a look here at this next map. This is the last run of the NAM. Okay, I'll leave my yellow lines on here. What do you see? Less precipitation on the last run at 84. So the new run, more precipitation farther west. The last run of the NAM had basically nothing for me, and then this blue line was back farther here. The 1 inch line was off to the east as well. So maybe there's a trend. Maybe we can see the next run of the NAM even bring all of this in even further. We'll see. We'll watch the 12Z runs come in throughout the day. So we're going to have to just watch this all the way up until game time. Here's the NAM snowfall output. It likes more warm air coming in, so more freezing rain and sleet. National Weather Service out of Raleigh, in their discussion this morning, actually acknowledged that there could be more in the way of freezing rain. Some of that has to do with saturation, where the snowflakes form. If you don't have good saturation there, you don't get snowflakes forming, but you could still get precipitation. It just would be more in the form of liquid precipitation that could freeze before it hits the ground or freeze on contact. So important things to watch, plus the warm layer. The NAM's going to see more warming in the lower and mid levels. And then there is the 12K at 84. So similar footprint to, I think, what the GFS was showing. And so, you know, it just pulls back and you see little light snow. So very, very meager event on the 84K NAM. The 3K NAM gives us a little bit better hope. Again, this is going to be where you don't see snow. There's going to be more ice, but it could be a very impactful winter storm if everything comes together. So that is the show for today. That is plenty of analysis. Hopefully it helps you kind of understand what we're looking at as we go into the work week and figure this all out. Lots of energy coming together, cold air in place, and if everything comes together the right way, we'll get a winter storm of some type, and we'll still iron out the details over the next couple days. So that brings us to a new segment that we're going to unveil today called Mailbag Mondays. We're going to take questions on Mondays from viewers, from comments in the comment section, or people that just randomly ask me a question about the weather, and I'll do my best to answer it. And so today's question comes from Carol, and she asks, why is it so difficult to forecast snowfall? Well, that is a really, really good question. And the answer is there are nuances that, you know, things that are very nuanced that can change just a little bit that can impact snowfall. We've talked about some of those here, warm layers in the atmosphere, and understanding how deep those warm layers are and how warm they are and if they exist at all. And modeling is not good enough to tell us exactly how that kind of thing might play out several days in advance. Even when you get a few hours before the storm, you can have a pretty good idea of it, and you can gauge a probability of a warm layer, and then understand, you know, how that's going to affect precipitation as it falls, and then change the form of that precipitation from snow to sleet or ice or something like that. But it's still not possible to model it in such a way that it's very accurate and exact. And so you have to sort of guess, use your instinct on it. And the other thing that can kind of play into it as well is precipitation amounts. So the same rules apply. Modeling can tell you generally what is going to happen in terms of precipitation, but we've seen that today. You know, several different models might have different precipitation outputs. There's no perfect solution because we can't perfectly model the atmosphere. And even if we could model every point in the atmosphere and observe every point and put it into a computer model, we don't have the computing power to extrapolate that out in time. It would take weeks. By that time, the forecast period would be behind us. So we can't do that. So the best we can do is kind of use our judgment when we see all these different models that are out there and put that together. Small changes in precipitation amount make big changes in snow. When a forecaster says, hey, it's going to rain tomorrow, and it rains, you don't care, right? It might rain 0.2 inches, it might rain 0.4 inches. You're not observing that, so you don't care. But in the winter weather world, 0.2 inches of precipitation, liquid equivalent we call that, versus 0.4 inches of liquid equivalent could mean the difference between 2 inches of snow and 4 inches of snow if you use the standard 10-to-1 ratio. 1 inch of precipitation equals 10 inches of snow. And there are factors that can change that. How saturated is the air column? How cold is the air column? Those, you get a really saturated, really cold air column with good lift in the snow growth zone, you're going to see better ratios, maybe 15-to-1. So a lot of things can factor into snowfall forecasting. Warm layers can eliminate some of your snow, and lower precipitation can eliminate some of your snow. So the takeaway is small changes can make big differences in snow amounts, and those small changes have to be evaluated and attempted to be forecast by a meteorologist. And those things, we just don't have the capability from our modeling and data observation to be able to do that extremely accurately, down to the 1/10 of an inch of precipitation. So we can kind of get it close, but sometimes things still happen in the atmosphere. That warm layer might push in quite a bit farther than was anticipated by any of the models. And now you're looking at sleet or freezing rain where you thought you were going to get 6 inches of snow. That happens all the time, and that's the reason for it. So I hope that helps. Now, our last segment here is the wrap up of our trivia question. We need to answer that trivia question, right? What type of fog forms when warm, moist air moves over a cold surface? And the answer is advection fog. Fog comes in over a warm lake, warm surface, and or I said fog comes in over a warm lake, a cold layer or a warm, moist layer of air. I've got this all completely backwards. A warm, moist layer of air comes over a cold surface, and the air saturates, and you get a low cloud, which we call fog. So you'll see that happen sometimes, particularly when you have cold bodies of water, ponds around. You'll drive down the road and you'll see a pond, and it'll have fog over top of it, right? So that's what that is. So that's our show for today. Hope you had a good time, and certainly hope you have a great rest of the day and upcoming week. Tune in tomorrow for another episode. We've got more to cover. And with that, this is Cold Rain reminding you, if you didn't like the weather you saw today, there's always a better model out there somewhere. It's your job to go and find it. All right? Take care.